we are going to learn what are zeros of a polynomial, how to find them, and then we will follow with what is remainder theorem. Okay. So first, what is a zero of a polynomial? When p alpha equals to 0, then alpha is a zero of the polynomial px. Now, what does it mean? It means the original polynomial is px. Okay. I have replaced x with alpha. So whenever we replace x with any value in the given polynomial, and if we happen to get 0 after solving it, that means the value we had substituted is nothing but a 0 of the polynomial. Let's try to understand better with the help of a quotient. Now, the quotient says, check whether 2 and minus 2 are zeros of the polynomial x plus 2. So what I will do first, I will name the polynomial p of x. Now, it is not necessary that every time you have to name it only px. You can call it g, f, h, anything with x, because x is being used as the main variable of your polynomial. Okay. So px equals x plus. Now, as I told, we have to replace x. So the replacement is going to take place on the left as well as on the right. I am going to replace this x also with 2 because I am checking for 2 first. And the substitution of the replacement will take on the right side as well. So what we get, p of 2 comes out to be 4. Now, this is not equals to 0. That means 2 is not a 0. Okay. Now, let's check for the second value, which is minus 2. We will replace x of the given polynomial with negative 2. So we get negative 2 plus 2, which is 0. Now, what we will conclude that negative 2 is a 0. So here we saw that when we replaced x with any value, if we are getting after simplification a 0, the value is a 0. Otherwise, it's not the 0 of the polynomial. Okay. Let's do another question before we move on to remainder theorem. The question says, find the 0 of the polynomial px equals to x plus 3. And then there is another part, 3x plus 2. Okay. So let's start for the first one. We have px equals x minus 3. We need to find a 0. We are not given any 0 to check, but we need to find it. And when we are supposed to find the 0, we will just equate the polynomial equals to 0 and solve it as a linear equation. Okay, so let's do that. X minus 3 equals to 0. You know already how to solve a linear equation. So 3 goes to the other side and we get the value of x as 3. That means 3 is your 0 for the given polynomial in first part. Okay, let's do the second one. Now p of x equals 3x plus 2. Right? I will equate this also with 0. As I told earlier, whenever you're solving for a linear polynomial, you have to equate it with 0 and solve it just like a linear equation. So now 2 goes to the other side and turns negative. And now 3 will get divided. Negative 2 will get divided with 3. And hence, your 0 is negative 2 over 3. Just for curiosity purpose, let's substitute this value back in the polynomial to check if we are really getting a 0 upon its substitution or not. Okay. So what I'm doing, I'm substituting negative 2 over 3. So this comes out to be 3 times negative 2 over 3 plus 2. 3 and 3 gets cancelled. I am left with negative 2 plus 2, which is 0. And therefore, we are correct that yes, negative 2 over 3 was a polynomial was a 0 for the polynomial 3x plus 2. I hope what is a 0, how do we find it, and how do we verify it is clear. Okay. Now, let's move on to the next topic, which is remainder theorem. You will find many questions in various books, and they are important actually, because the questions around remainder theorem can be as short as 1 marker and they can be as long as 4 marker also. Okay. Now, first of all, what is a remainder theorem? When we substitute zeros in the given polynomial to find the remainder. So that means what we are doing, we are given a polynomial. We have learned what is a zero. If we are substituting that zero in the polynomial to see what we are getting on the right side, the value that we are getting on the right side is nothing but your remainder. It may be zero, it may be something else. Okay. So let's start with the question now. Find the remainder when the polynomial px is given to us as this one is divided by x minus 2. Now, we are given an expression over here. We are not given any value, but we are given an expression for which we need to check. Okay. So what we have x minus 2, we are given told that gx is x minus 2. So from here, first we need to find a 0. And what do we do to find a 0? We equate the polynomial with 0, and this polynomial is x minus 2. So equating this with 0 gets me x equals 2. Okay. Now, we are given the polynomial px and just rewriting the whole polynomial. It is x to the power 4 plus 2x cubed minus 3x squared plus x minus 1. So now we need to substitute the value of 2 over here, and that comes out to be 2 to the power 4 plus 2 times 2 cube minus 3 times 2 square plus 2 minus 1. We will just solve it. 2 to the power 4 is 16. 2 cube is 8 times 2 is again 16. 2 square is 4. 4 times 3 is 12 plus 2 minus 1 is 1. So what do we get over here? 16 plus 16 is 32. 32 minus 12 is 20, and 20 plus 1 is 21. So what is this? The value that we have just got is your remainder. This is your remainder. So we just saw that how to find a remainder when we are given a polynomial, and we established the 0 also from a given factor. X minus 2 was a factor. Okay. So now we have got another one over here, which is find the remainder when the polynomial is x cube minus 3x squared plus 4x plus 50 divided by gx equals x plus 3. This question is absolutely similar to what we have just solved. Okay, so the method is going to be absolutely same. Gx equals x plus 3. Now, the first step, equating it with 0, that leaves us with x equals negative 3. Okay, now we will rewrite a polynomial, which is x cube minus 3x squared plus 4x plus 50. Remember, what is the next step? Substituting the 0 that we had just established. It was negative 3. So, negative 3 cube minus 3 times negative 3 square plus 4 times negative 3 plus 50. Okay. We get negative 27 over here. Now, negative 3 square is 9. 9 times 3 is negative 27 again, minus 12 plus 50. This comes out to be negative 54. Negative 54 minus 12 comes out to be negative 66 plus 50. And hence, the remainder that we are getting over here is negative 16. So, P of minus 3 is 16. This is nothing but your remainder. So this is how we use remainder theorem in the polynomials. I hope you have learned in this video what is 0, how do we find the 0, how do we verify the 0 with a given polynomial, and then what is remainder theorem and how do we apply that. Happy learning!